Hi everyone, we're in part 4 of section 4.1. We have been talking about how to graph equations, and we graphed an equation using a table of values. We graphed a function using slope-intercept form. Now we're going to talk about how, given the equation of a linear function, use transformations to graph the linear function in the form f of x equals mx plus b. So first, in order to do that, we talked about transformations a lot in, I believe it was section 3.5. And so some of this should sound familiar. So the first thing they tell us to do is, if you're going to use transformations to graph a linear function, is you have to start with the parent function, which is the identity function, f of x equals x. So if you will remember, that's the line that goes through the points 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. It goes right through the origin. And then from there, make your vertical stretches or compressions by the slope factor. And then from there, you're going to shift the graph up or down b units. So let me just show you here. This is in black, what I'm graphing. This is your identity function. And you would start here. I know you see all these graphs, but these are the graphs of the lines over here to the left. So if we were looking at this function here, 2x plus 3. So let me just start with the identity function. And I'm going to start with, I'm just going to name 5 points on the identity function graph. And they're easy to name because the x always equals the y. Okay, so for this graph right here, for the identity function, for the function f of x equals 2x plus 3, if we're using transformations, we'll start off with the identity function, which I have graphed here in the black dotted line. And those are the points negative 2, 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, so on and so forth. So the first thing that you would do is you would vertically stretch or compress the graph by the factor of m. So what we're going to do is we're going to stretch it by a factor of 2. So I'm going to multiply all of my y's by 2. And my new y coordinates are negative 4, negative 2, 0, 2, and 4. And from there, this number here tells me to do a shift. So I'm going to now shift up 3 units. So now I'm going to go up 3. So I'm going to add 3 to each of my, and this was a 2, to each of my y's. So now my new y's are negative 1, 1, 3, 5, and 7. So I have the points negative 2, negative 1, negative 1, 1, 0, 3, and 1, 5, and 2, 7. And it says match each equation with a linear function of the linear function with one of the lines. So if I have the point negative 2, negative 1, negative 1 up 1, 0 up 3, 1 up 5, 2 up 7 doesn't fit on the graph, but you can see it's right here. It is the red line. This here is y equals 2x plus 3. So you can pause the video and you can go and you can try to use transformations to match each of the graphs. Now, I know you can just as easily use slope-intercept form, which I think is probably easier to do, but it is good practice to practice the transformations. So why don't you pause the video and then see if you can match each graph with the remaining three. Okay, hopefully you try to do the transformations for each of these. For B, it was a vertical stretch of 2, and then we shifted down 3. So that's going to be this green graph right here. So this green graph is B. Y equals 2x minus 3. And then H of x, letter C, after it was a vertical stretch of 2 and then a reflection over the x-axis, and then it shifted up 3, so that would be the B. I'm sorry, the blue graph. So that's letter C. And then D is J of x. That shifted up 3, but it was a vertical compression, so it's not as steep. So it's going to be this orange one here, y equals 1/2 x plus 3. So again, there are multiple ways to graph. You can make tables of values. You can do slope-intercept form, which I use often. Or you can do transformations, which is what we learned in Chapter 3, but transformations of the parent function, which is the identity function y equals x. Okay, so now we're going to talk about writing the equation for a function from the graph of a line. So let's talk about x-intercept. The x-intercept of a function is the value of x when f of x equals 0. So probably the way you learn this in the past is x when y equals 0. It can be solved by the equation 0 equals mx plus b. So basically what happens is if it says find the x-intercept, what we're going to do is we're going to replace the f of x with 0, and we're going to solve the equation. So in this case, I would add 4 to both sides, and that leaves 4 equals 1/4 x, because the 4's cancel. And then you're going to multiply both sides by 4, the reciprocal of 1/4, which is 4. And on the left I get 16. On the right I get 4 over 4, which is 1x. So x equals 16. This is the x-intercept. So it is 16 when the y equals 0. So this is the point 16, 0. So what this means is this graph crosses the x-axis at the point 16, 0. That's what that means. Big picture. Okay, so now let's talk about two special types of lines, horizontal and vertical lines. Lines can be horizontal or vertical. We've dealt with slanting lines that weren't horizontal or vertical. But a horizontal line is defined by an equation in the form f of x equals b. In this case, the slope equals 0. We talked about flat lines like that, horizontal lines. Horizontal goes this way, by the way. And how the slope of those lines would be 0. So f of x equals b. So f of x equals some number. Then a vertical line looks like this, straight up and down, is a line defined by the equation x equals a. So notice there's no y, there's no f of x, it's just x. X equals a. In this case, just so you know, slope is undefined for vertical lines. So example, write the equations of the graph lines. So this is a horizontal line. Okay, this is horizontal. So horizontal lines are f of x equals b. B is where it crosses the y-axis. It crosses the y-axis at 3. Actually, it crosses all lines at 3. All the points here have a y-coordinate of 3. So f of x equals 3 would be the equation. This is a vertical line. And as I said above, vertical lines have the equation in the form x equals a. A in this case is what x equals. So what does x equal? On the x-axis, all of these points have x coordinates that are -3. So in this case, x equals -3 would be the equation. So horizontal and vertical lines just have one number really in the equation. It's x equals a number for the vertical line and f of x equals a number for the horizontal line. Alright, so now we are at the point where we're going to talk about parallel and perpendicular lines. So two lines are parallel lines if they do not intersect. So parallel lines, they don't cross. And the slopes of these lines are the same. Okay, so I'm going to highlight that because that is important. The slopes of the lines are the same for parallel lines. That's how you can tell if two lines are parallel, because their slopes are the same. So f of x equals m1x plus b1. And we say have the ones there because that's line 1. And g of x is m2x plus b2. They're parallel if and only if m1 is equal to m2. So basically what we're saying is these two lines can only be parallel if their slopes are equal. And if and only if b1 and b2 and m1 and m2 are equal, we say the lines coincide. What that means is if your slope and your y-intercept are both the same, you basically have the same line. Okay, so that's what it means when lines coincide. It means they are the same line. Okay, so then we have perpendicular lines. Perpendicular lines, they do intersect. So parallel lines do not intersect. Perpendicular lines do intersect, and they form a right angle. Right angle is a 90-degree angle. So it's basically the intersection of a horizontal and a vertical line. Although you can have two slanted lines intersect and also form a perpendicular line as long as they have a right angle formed when they intersect. So f of x is equal to m1x plus b1 and g of x is equal to m2x plus b2, and they're perpendicular if and only if when you multiply them times one another, they equal -1. So if you multiply the slope of the first line times the slope of the second line, if the product of those two slopes is -1, then it's perpendicular. What that also means is that the slope of one line is the opposite reciprocal of the other line. So they are opposite and reciprocal slopes. And so opposite means a different sign, and reciprocal means when you flip it. So like the reciprocal of 3 would be 1/3. So the opposite reciprocal of 3 would be -1/3. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. But you can also, like I said, you can multiply them together and see if you get -1. That's another way to tell. So let's identify lines that are parallel or perpendicular. So given the functions below, identify the functions whose graphs are a pair of parallel lines and a pair of perpendicular lines. So next to each one, I'm going to write the slope. So the slope of f of x is 3. and the slope of g of x is 1/3, and the slope of h of x is -3. Remember, slope is the number in front of x. And the slope of j of x is 3. All right, so let's pick out the ones that have the same slope. So f of x and g of x, I'm sorry, j of x, f of x and j of x are parallel because they have the same slope. Now, in order to be anything else, a perpendicular slope, then you have to be opposite reciprocals. So I believe that opposite means they have to be different signs. So 1/3 is the reciprocal of 3, but it's not opposite. So this can't be perpendicular. F of x and g of x can't be perpendicular. But it's possible that g of x and h of x are perpendicular, because I believe 1/3 is the opposite reciprocal of -3. But we can check it if we take, I'll call it the slope of g of x times the slope of h of x, because I think they're perpendicular. If I multiply them together and I get -1, that means they're perpendicular. So 1/3 times -3 equals -1. So that means g of x and h of x are perpendicular. And then let me just say this, because I don't see this anywhere on this slide, but I just want to show you that parallel lines, they have this notation. That is the notation for parallel lines, and this is the notation for perpendicular, an upside down T. Okay, so if we're writing the equation of parallel or perpendicular lines, the first thing that you're going to do, so this looks like this is the steps for parallel. So a line that's parallel to a given line. So you find the slope of the function, substitute the given values into either the general point slope equation or the slope intercept equation for a line, and then simplify. Then if you're doing a perpendicular line, you find the slope, then determine the negative reciprocal of the slope, substitute the new slope and the x and y values from the coordinate pair provided into g of x equals mx plus b. Or honestly, you can put it into the point slope form again. Solve for b, write the equation. So either one of these, you do have the option for using point slope form. So given the function f of x, this should say equals 1/3 x plus 1, it says write an equation for the line passing through the point 2, -3 that is parallel to f of x and perpendicular to f of x. So we're going to do two problems here. We're going to do part A. We're going to do a parallel line. And then part B, we're going to do perpendicular. So for parallel, what we're trying to find is the equation of a line that is parallel to 1/3 x plus 1, and it passes through the point 2, -3. That's what we're trying to find. So first, identify what the parallel slope is. So the slope of the function is 1/3. So the slope of your parallel function is also 1/3. So what we do is you can, I'm going to do point slope form. just because I like it. I told you that I liked it before in a previous video. So I'm going to use point slope formula. So y minus y1, which is negative 3, equals m, which is 1/3, times x minus x1. x1 is 2. Then I'm going to distribute the 1/3 on the right. On the left, I'm going to make that a plus, y plus 3. So I end up with y plus 3 on the left equals 1/3 x minus 2/3 on the right, because 1/3 times x is 1/3 x, 1/3 times negative 2 is negative 2/3, and then I want y by itself, so I'm going to subtract 3. What I do to one side, I do to the other. So on the left hand side, I'm left with y because the 3's cancel. On the right, I have 1/3 x minus negative 2/3. I'm doing this on the side. Minus 3/1 is the same as 9/3. And 9/10. So that would be minus 11 thirds. Now you could have plugged it into y equals mx plus b and solved for b as well, and then plugged in your m and your b at the end, but this works just as well. Now, to find the line that is perpendicular to that, first we identify the slope of the function, which we already identified earlier, but we'll identify it again. It's 1/3. So the slope of this line is 1/3. So that means the slope of the reciprocal is the opposite. So negative, and then reciprocal, opposite reciprocal. So if we flip 1/3, we get 3. So the slope of the new line, of the perpendicular line, is negative 3. So I'm going to use point slope again because, again, I like it. I think it's just easier to deal with. That way you don't have to worry about plugging numbers in at the very end when you find b. So I'm going to do the same thing. I'm going to plug in my x1 and y1, and then I'm going to plug in my new slope. So I have y minus y1, which is, the point was 2, negative 3. So y1 is negative 3. M this time is negative 3. Parentheses x minus 2. So this becomes y plus 3 on the left equals, distribute the negative 3. We get negative 3x plus 6. And then we subtract 3 on both sides. And on the left it cancels. On the right we add it to the 6 and we get negative 3x plus 9. So negative 3x plus 9 is the line that is perpendicular to f of x equals 1/3 plus 1. That also passes through the point 2, 3. Okay, so you guys pause the video, try this one, and then we will go over it. Okay, so we're finding the slope, we're finding equations for the line that passes through 0, 0. That is parallel and perpendicular to h of x equals 2x plus 4. So the slope of 2x plus 4 is 2. So the parallel slope would be 2. The perpendicular slope would be the opposite reciprocal, so negative 1/2. So for parallel, let's do y minus y1 equals m times x minus x1. So for the parallel line, y minus y1, which is 0, getting that from right up here, equals 2, because that's the slope of the parallel line, times x minus 0. So we end up with y on the left because the 0 goes away, and on the right we end up with just 2x. So there we go. We're done with the parallel one. Then for b, the point slope form, y minus y1 equals m times x minus x1 again. So y minus y1, which is 0, equals m, which is negative 1/2. times x minus 0. Again, the zeros go away, and you're just left with y equals negative 1/2 x, and we're done. All right. So now we're going to write the equation of a line parallel or perpendicular to a given line. So a line passes through points negative 1, 5, and 3, 4. Find the equation of the parallel line that passes through 4, 5. So basically, we've got a line that goes through these points. We want the parallel line that's going to go through those points. So for line 1, we need to find the slope. So remember, slope is y2 minus y1 over x2 minus x1. I'm finding the slope because that's really the starting point. You need to find the slope of the line because the parallel slope would be the same. So we'll call that x1 and y1, x2 and y2. So I end up with 4 minus 5 on the top, 3 minus negative 1 on the bottom. 4 minus 5 is negative 1. 3 minus negative 1 is 3 plus 1, which is 4. So I end up with 1/4. So the slope of the parallel line is also 1/4. So now I'm going to take this 1/4 here, and I'm going to put it into my handy dandy point slope formula. And I'm going to just pick, I'm not going to pick either one of these points because what I'm doing now is I don't need the equation for this line. I need the equation for this line here. So the equation of the line that is parallel to this one but passes through this point. So this is my x and my y that I'm going to use now. So in this case, y minus y1 for this new line is 5 equals m, which is negative 1/4, times x minus x1 for this line, which is 4. So I end up with y minus 5 equals, distribute, negative 1/4 times x is negative 1/4 x. Negative 1/4 times negative 4 is positive 1. And then we would add 5 to both sides. And it looks like we end up with y equals negative 1/4 x plus 6. That's the equation that is parallel. We're doing parallel. Had we been doing perpendicular, we would have flipped the negative 1/4 and made it positive. Alright, so now you guys try it, but this time for perpendicular. So pause the video and then come back and we'll go over it. Alright, so this time we're doing a perpendicular line that passes through 6, 4, but it needs to be perpendicular to the line that passes through those 2 points. So we're going to start by finding the slope of the original line. So slope is y2, which is negative 3, minus y1, which is negative 15, over x2, which is 2, minus x1, which is negative 2. So negative 3 plus 15 is 12, and 2 plus 2 is 4, so my slope is 3 of the line that passes through negative 2, negative 15, and 2, negative 3. So the slope of the perpendicular line would be the opposite, so negative, reciprocal. So the reciprocal of 3 is 1/3. So the slope of the perpendicular line is 1/3, and it passes through 6, 4. So that's my x1 and y1 for the point slope formula. So here we go, point slope formula. So we have y minus 4 equals negative 1/3 x minus 6, distributive property, and we get negative 1/3 x plus negative 1/3 times negative 6 is positive 2, and then I'll add 4 to both sides, and we get y equals negative 1/3 x plus 6. So the line that is perpendicular to the line passing through -2, 15, and 2, 3. The line that's perpendicular to that and passes through 6, 4 is y equals -1/3 x plus 6. Alright, so that is it for this section 4.1. If you have questions, please let me know.